welcome to the Department of Computer Science and Emiliano's inaugural lecture. One of the great pleasures of being a head of department is, and there are some, is that you get to go round different bits of what is a huge and complex department. And what you see when you do this is you see everywhere that there are pockets of absolute brilliance, real deep, important research everywhere. Yeah. This is an example of one of those. I'm pleased he's taken it, as I said, I'm pleased he's taken it really seriously and made an effort, and I'm sorry that I haven't. Anyway, so it is my very great pleasure to introduce Emiliano. He is a world-renowned researcher in his field. I couldn't have been more pleased to see him promoted to professor, and it wasn't before time as well. The area of security is clearly a really very important one for society as a whole. And that rests on fundamental research. The application of that rests on fundamental research that is done well in relatively few places. Again. All of that relies on people. It relies on individuals. It relies on leaders in their area. Emiliano is one of these people and has become a really very effective leader of the security activity at UCL. So I'm going to shut up and let Emiliano talk. We're in for a really very interesting time here, and we'll let Jean wrap up later on. So, Emiliano. Oh, you're going to get the mic. No, I was going to sit.
Thank you. Well, thank you very much, Steve, and thank you very much, Vajia and Tanya, for organizing this. I really appreciate it. What can I say? I'm really, really honored to be here and to have you all celebrate my inaugural lecture. I admit I'm much more nervous than I thought I would be, and primarily because I'm supposed to talk about my research and the work that led me here, that made it possible for me to be at UCL and to be a professor. But there's really no such a thing as my work, right? It is without any doubt that none of this would be possible without the work of so many people that have provided so much advice and support and worked for me and with me over the years. So I'm truly, truly humbled. Also by having so many people be here, coming, despite challenging times, also from far. So anyway, so I'm going to try and give sort of a personal view over the last dozen years of research, and in particular on two topics that sort of kept me up at night and kept me busy, privacy and cyber safety. And if you have any questions, please do stop me anytime or just buy me a drink after. I mean, drinks are free, but after the talk, and I'd be happy to chat. Okay, so let's get started, right? So hopefully I don't have to convince you very hard that privacy is very important, and in many societies, in many cultures, is a fundamental human right. I'm not even going to try and define what privacy is. Many scholars before me have tried and maybe somewhat failed. So it's a very contextual, very sort of personal thing. But as computer scientists, and in particular as security experts, we try to define privacy as a set of security properties, right? So, for instance, you reason about confidentiality and the goal of keeping secret information, secret, or control. So giving the ability to individuals to choose to control who and how can use their personal information, as well as self-actualization, so allowing people to use their information for their own benefit and not only the benefit of giant evil corporations and big brother governments, right? But obviously there is much more to privacy than technology and engineering. So our work needs to be informed by a lot of work that is done in other fields like sociology, law, psychology, economics, and so on and so forth. We cannot work without taking those aspects into account. Right, so in particular, I've been very lucky to be part of a research community around what we call privacy-enhancing technologies, PETs. In fact, there's even a conference called PETs. And it's actually around 2009, I think I went to my first PETs conference in Seattle. And that's really when I kind of got convinced that that's what I should be doing with my life. With my PhD, let's say. So that's the field I wanted to work on. There were so many researchers in that conference, so engaged, so passionate, and being very lucky to then become colleague with some of them, like Stephen, George, and so on. So it's been really, really an honor. So overall, the PETs community has a lot of sort of interesting research problems that I've been working on, probably since we can start from the 80s with the work of David Chalmers, who once just called me in the office, and it was like the equivalent of somebody who's really into football being called by Maradona, okay, so it was really an interesting experience. Anyway, so we work on many different privacy problems, and this is just a non-comprehensive list of them. So the icons were supposed to be cool, but the projector kind of messed them up. Anyway, so like mitigating privacy threats, so violation of privacy by malevolent actors, trying to increase privacy of users, organizations, groups, and so on. But also, and one of the things that I focused on during my PhD has been to enable computational scenarios, or let's say applications, that will be otherwise impossible without really strong, sound privacy guarantees. Okay, so I'm going to try to give you some examples of this, and in particular in the context of information sharing. Right? So, you might have some applications, some situations where two or more parties, companies, organizations, users, and so on, that don't really trust each other, might be willing or might be compelled to share information with each other. Right? So you have a little bit of a chicken and egg problem. How do you solve this? Well, we define the problem as making sure that you can share information as long as only the minimum required amount of information is disclosed in the process. And we're going to try actually to define this formally and provably. Okay? So let me give you a sort of a concrete example. Let's think about two investigative authorities, let's say the CIA and the FBI. And actually, I picked this example because part of my PhD was actually funded by an IARPA grant. So IARPA is the intelligence agency, research agency in the US. So, these are two agencies that are, different animals, right? So one is under the Department of Defense, one is under the Department of Justice. And, in theory, like say the CIA should collect intelligence abroad, and the FBI in the USA. Right? I'm oversimplifying a little bit, right? So you can think that, maybe sometimes they investigate the same people, right? Let's say terrorists, and, it might be a good idea for them to share information so that they can advance their investigation. Well, actually, that's not really possible, right? So there are different jurisdictions. There is some restrictions that actually, if you've, that have been very well known with post 9/11. Okay, so on the one hand, they should be able to share intelligence; it'd be useful, but in practice, they can't. So was actually a TV show, a Hulu TV show, I think in the UK it was on Amazon Prime, called The Looming Tower, where actually really they look at the days before 9/11 and how the FBI and CIA were not sharing information with each other, were not really talking to each other. I think they actually don't like each other, but anyway. So how can we go about solving this problem? So let's simplify it a little bit. So let's say the CIA has some database of suspect terrorists. The FBI has also this, like another database. So what you want is for them to find common suspects, right? So essentially, if you think about these databases as sets, what you want is the intersection of these two sets. So like intelligence related to common suspects, right? And so you want to have an algorithm, a primitive, that allows you to find the common suspect and nothing else, okay? And this is actually possible. It's defined through a primitive, through cryptography, so a cryptographic protocol called private set intersection, okay? And that's why, when I was watching this looming tower, it was really bad for my wife, because every 5 minutes I was saying, just use private set intersection, that prevents 9/11, and okay, that didn't happen, right? Anyway, so let me define the problem, right? So I'm now moving away from FBI and CIA. I'm talking about two entities, let's say a server and a client. The server has a set with W items. The client has a set with V items. So what you want is to have a protocol, some interaction between these two parties in such a way that at the end of the interaction, the client gets the set intersection and only the set intersection, right? So it will not learn anything about the items in server set that are not in common, that are not in the intersection, right? And so here, this is a little bit asymmetric, right? So the server, you see there is no arrow, no output out of this primitive, so the server actually learns nothing at all, like nothing about anything about client set, right? So if you had, a godlike trusted third party in the sky, you could easily implement this functionality. The server and the client will give them their sets, and the trusted third party will compute the intersection and give the result, right? So really the goal is to replace this trusted third party with cryptography. And we can actually prove that the protocol doesn't leak anything as if we had the trusted third party. Okay, so this was around 2009 or so, and we knew how to. We had a few solutions for private set intersection. We knew sort of how to do it. So really, the two biggest challenges that we had to focus on were efficiency and what I call accountability. Okay, so efficiency essentially relates to how long it takes for you to run these protocols, right? And so this comes from the fact that these protocols involve sort of expensive cryptographic operations. So for instance, modular exponentiations, and this may be like 2-3 orders of magnitude more expensive than computing hash functions. So if you ever played with systems, you know that cryptographic hash functions actually are not even are not really fast in the first place. So this is even more expensive than that, right? So really we did a lot of work trying to optimize operations, so move as much as possible computation offline, do batching and a number of things. So the other thing is actually relates to the fact that the confidentiality property that you want to guarantee means that no matter how big the intersection is, the server has to touch, has to process, has to do some computation for each item, and the client for each of its item, and the client the same, right? So, and in computer science, we measure the complexity of an algorithm in terms of the size of the input, right? So this allows us to sort of abstract away the details of the implementation, the hardware, and so on, right? And so if we say if the server has W items and the client has V items, we can measure complexity of set intersection protocol based on these parameters W and V. Okay. So overall, at that time, we had solutions that were sort of quadratic in the size of the sets. So it was W times V. And we had protocols that allow us to go to linear complexity, W plus V. So if you think about it, when you have very big sets, this makes a big difference, right? So it really allows you to scale these protocols much better in the real world. Okay, and the second problem was what I define accountability. To be honest, I'm not really sold on this this word, but anyway. So what is the problem, right? So if we look at this picture, right, we see that the server doesn't learn anything about the client's input, right? So this is a feature that we want to provide. So we have some confidentiality property, but what prevents the client from just misbehaving, from inputting whatever it likes, right? In an extreme case, the client could actually try and enumerate all possible items, could input the universe set, right? So the intersection between the universe set and any set is that set, right? So technically, the functionality does what it should, gives you only the intersection, but what does that mean in practice, right? So, so we realized that we had to sort of come up with an idea to capture authorization of input, or let's say policy compliance, right? But you have again a chicken and egg problem, right? So if we had to just show this authorization or demonstrate policy compliance, then we will give up the confidentiality property, right? So we had to find a way where these authorizations were checked implicitly, so without revealing them. So in a sense, this is sort of a zero-knowledge proof. We don't actually use zero-knowledge proofs, but it's kind of the similar concept, right? And this was, a big step forward in sort of the applicability of these protocols. Okay. All right. So overall, we did a lot of work on this stuff. Okay. So we had several variants of these protocols. For instance, we could only protocols that would reveal only the size of the intersection, not the content. I sort of lied to you in that when I said, let's say the server doesn't learn anything about the client set, well, actually learns its size, and sometimes that's a problem. So we had also an extension where we could hide the size of the client set, and especially in this project that I mentioned for the IARPA, we did a lot of work sort of transitioning from, let's say, simple set items to database records. And so we kind of had a way to simulate, let's say, database queries, sort of like SQL database queries. So you do these queries in a privacy-preserving way. Okay, so there was a little bit more sort of systems work rather than cryptography work. Okay, and this was like 2009, 2010, and so it was quite some time ago. But actually, private set intersection kept being sort of a hot area even after I stopped working on it. And so you see in top conferences, you still see at least one paper somewhat related to it. So one of my colleagues actually made this meme of myself saying I worked on PSI before it was cool. And I posted it on Twitter. It was very embarrassing, but I think I look pretty good here. All right. So anyway, so then toward the end of my PhD, and then when I moved to Xerox PARC, I really started working more on applications of these protocols, right? And so we did a lot of work on collaborative threat mitigation, allocation data, social networking, and even genomics. So this is also a topic that has been really sort of dear to my heart. We've done a lot of work with people in this room as well, and so on genomic data, and use this. So first of all, understanding what privacy issues are in the context of genomics, and sort of the key challenges that genomic data has with respect to security and privacy, and then use some of this protocol to actually try and support privacy-preserving testing on genomic data. So we've done a lot of work on that. Unfortunately, I don't have time today to talk about this. But it's interesting for me, like as I was going through this journey, right, that we actually had sort of more luck publishing in top-tier conferences on the applications than on the protocols themselves. So, in a sense, sometimes you got to build a whole house before you can sell it, right? So it's not enough to sell the building blocks, right? So we did all right, but it was interesting for me. Like the papers that I was most maybe proud of in terms of contributions, maybe were published in good places, but the top tier papers that I had were on the application side. Okay, I mean it's just an observation. Okay. All right, so then we kind of over the years we went maybe a few steps further in that we went beyond data sharing, and in particular like releasing information and learning from information. Okay, so I have to take a side step here for those of you who are not familiar with, say, machine learning. Okay, so I'm going to oversimplify a little bit, but essentially I'm going to talk about how we can train machine learning models to do some learning tasks. Okay, so for instance, let's consider a model that we want to train to learn to recognize pictures of cats from pictures of dogs, okay? So what you do is that you collect enough samples, right? And there are labels, so this is a picture of a cat, this is a picture of a dog, and you go through a process called training, so where you train a model that then on unseen data, on pictures that it had not seen during training, can tell you this is a picture of a cat or a picture of a dog, right? So this is called supervised learning, and this is a classic example of what's called a discriminative model, right? So given a picture, let's say, of a cat or a dog, the model makes a prediction and tells you this is a picture of a cat, okay? So there's also other kinds of models, for instance, like generative models, that estimate the underlying distribution of a data set and can be used to randomly generate realistic samples according to that estimated distribution. So for instance, given enough pictures of cats, the model is able to generate a synthetic, an artificial picture of a cat. Okay, so for, as much as this cat is cute, does not exist in reality, right? So this is what an algorithm has generated artificially. Okay, so now back to privacy, right? So what we did was to look at situations where organizations might want or need to publish data set, to release their data set, right? So maybe they want to monetize it, or you have you're sitting on some very interesting data set, you want to make it available to researchers to do some studies, or for the greater good or for money, right? So and we have this sort of dream that we could maybe have some magic box where you input your raw data set and out of the box get some sort of sanitized, safe version of the data that you can put online, that you can publish, that you can give away, that you can sell, and so on and so forth. But this is very hard, right? So a lot of sort of attempts have been made over the years. So there are techniques like k-anonymity, L-diversity, and so on, which have been proven to be quite inefficient, quite ineffective. Okay, and then there's been other attempts of some called differential privacy, which I don't have time to cover today, that sort of are able to answer statistical queries about that data instead of actually releasing a version of that data. Okay, so our intuition was to use these generative models to try and release synthetic data sets. Okay, so more specifically, we use a generative model to model the distribution of a data set and publish the model, but guaranteeing that this is done in a privacy-preserving way. So if you have access to that model, you cannot learn anything about that training data sets. Okay? So now, okay, maybe pictures of cats and dogs, maybe you might think it's not important, privacy is not important, although pets deserve pets. Pets deserve privacy as well, I believe. But so imagine if these data sets are about mobility or like healthcare data sets. So it's very important that you don't reveal anything about those data sets themselves, right? So now we publish this model, and now anybody can generate a synthetic data set that resembles the original data with strong privacy protection. So why does that make sense, right? So in some cases, like you are not really interested in the data itself, but you're maybe interested in statistical properties of that data, okay? So for instance, like let's say if you have a mobility data set, let's say the London Transport Authority, you learn a lot about how people commute, how they cope with strikes and signal failures, and how they organize their, what stations get busy and when and so on. So in that case, you don't really care to know who's traveling, right? So you just care about these sort of statistical properties, right? So in this setting, this is appropriate to generate a synthetic data set, and you study that synthetic data set. So as long as you don't reveal anything about the original data, then you're fine from privacy perspective. And so we did this using some new deep learning algorithms like GANs, variational autoencoders, and restricted Boltzmann machines with this differential privacy. That again, like I said, sorry, I don't have time to cover. Okay. So the next step was actually to look at learning, right? So how we can use data to learn tasks. Okay. And so we really thought about what it means to reason about privacy in this setting, right? So on the one hand, we have seen in the past few years some tremendous progress in machine learning, or AI if you want to be cool, right? And this progress has been enabled by, yes, algorithmic breakthroughs, hardware advancements, so we have GPUs and TPUs, but also by the fact that we have more and more contextually rich information, contextually rich data that can be used to train these algorithms, right? And obviously, a collection of private data is not good for privacy, right? So having very sensitive information, it might not really be, might actually reveal a lot about sensitive information. So what we did actually was to try to come up with some sort of formal definition of privacy machine learning, right? And so we realized a couple of years ago that there are essentially two classes of attacks of privacy violations in machine learning. So one that is focused on inferring whether a data point is part of the training set. And this is called a membership inference attack. Right? So again, if the model, so the task that you're trying to learn or the data set is sensitive, let's say you have a model that, I don't know, predicts whether a smoker might get cancer, right? So if your data is in that data set and you learn that, that's problematic, right? So that's a membership inference attack. So the other class of attacks was called model inversion, or essentially you try to infer what class representatives look like, okay? And I'm gonna get back to this in a second, okay? So membership inference overall actually is a known privacy issue, not just in the context of machine learning. So in fact, you could think of the problem as following. So you have a function computed on some data, and an adversary wants to try to infer whether a specific data record of a specific user, a specific victim, was part of that data. Okay? So you only see the output of the function. You want to infer whether a specific record was part of the input. Okay? So very often, the function is aggregation. And there was some really cool work done in the context of genomic data. And then we did some work on mobility data. We actually got Best Paper Award in NDSS a couple of years ago. So overall, I think this is a well-known privacy problem. Like, I'm sold, right? I think it's clear. It's easy to explain. The other one, not so much, okay? So we got kind of in trouble because we were very sort of vocal that maybe that's not the way to go, okay? And so in a nutshell, what previous work was doing, and this was work coming out of top universities in the world, was trying to infer maliciously properties that hold for an entire class. So for instance, if you have a gender classifier, so some picture, and you want to determine gender of those pictures, you can infer what a male looks like, okay? But is that really a privacy violation? So to me, it tells me that machine learning works, right? So that the model is useful. So is learning something about the population from which the training data was sampled, right? So we said, I think we shouldn't define privacy violation as the adversary learns something about the training data. Instead, we should define it as the adversary infers some properties that hold for a subset of the training inputs, but not for the entire class. So put simply, if you have, again, a gender classifier, can the adversary infer uncorrelated properties like race, right? So that's what we studied. And we actually studied in the context of collaborative learning. And this is deployed in millions of devices by companies like Google. They call it federated learning, or Apple. So the idea is to train local models on your device and then refine this model through a collaboratively built joint model in such a way that your data never leaves the device, so you only exchange model updates, model parameters, something about the model. So this is good for privacy, right? So in fact, the number one application is predictive keywords. So if you have a Google keyword, you type hello, how are, you get a suggestion and the next word should be you, right? So this is machine learning, okay? And which is a model that is trained on your own data, what you type on your device. But the model is improved, has an accuracy, a better accuracy, because you get these updates from a collaboratively built model. But your data never leaves the device. So Google doesn't have to know what are you typing at all times. Okay? So this is good, and it's getting a lot of traction. So we studied these attacks in this context, and unfortunately we saw that unless you have hundreds of thousands of or millions of users participating, these privacy attacks are possible. Okay? So in the case of Google, you're still okay. You can still use Google keyboard. But in other settings, that doesn't really work. Okay? So what I wanted to show actually is, I think what I believe they're cool plots. So it's called a featured Disney projection. Okay? So I forgot to say that a lot of these algorithms are deep neural networks. Okay? So they're made up of many layers. Okay? And so this is like the fully connected layer. So at the end of the training, the model learns to distinguish gender, which was the task that was assigned to it. So you can see it learns to separate between circles and triangles. Okay, that's some kind of gender separation. Okay, but if we look at the intermediate layers, the model also learns to separate by race. So this pool 2 layer, you can see the blue and the red, which is a property like black, not black. So these are publicly available data sets that come with this label. These labels, anyway. So it separates these two things, right? So if you think about it, there's no intrinsic reason for a model to, that is learning gender to also separate race, okay? But it turns out that this was what happens with these deep learning models, and this is what the adversary, this kind of unintended extra functionality, is what leaks, and what the adversary can sniff out and exploit to mount this kind of property inference attacks. Okay? And so, I mean, there's been some follow-up work, and kind of we understand now why this happens, but this wasn't really something we expected. Okay? All right, so the second sort of set of things that I wanted to talk about today relates to cyber safety. And so a lot of this work sort of started around maybe 4 or 5 years ago. So we actually, because we got a really large EU project called ENCASE, that had some pretty legendary researchers on board, some really, like Mike, who's here coordinating the project. So we did a lot of work on what maybe in the UK is called online harms, and maybe in the US is called information weaponization, where essentially again, I don't probably have to work very hard to convince you that information systems and information in general is weaponized, is misused in many ways. So you have things like cyberbullying on social networks, coordinated hate campaigns, misogyny, like disinformation, and so on and so forth. Right? So, back then, we were writing the proposal, and then we got the project. With Gianluca was still here. He left. Okay, but so we thought, okay, what can we do, right? So we're security people, and we have experience with mitigating unwanted activity on social networks, right? So if you think about, let's say, spam or fraud or automated bots, right? Automated scripts like bots, right? So we know how to detect them, right? Why? Well, because we learn how to model them and find ways to recognize patterns of such behavior. Right? So, and this bot activity is large scale, is synchronized. So you can extract these features, you can recognize these patterns and build machine learning models like classifiers that recognize these patterns. Right? And we have some good results finding mitigating civil attacks and spam and fraud and reputation manipulation like fake likes and things like that, to some extent, right? So, but what can we do really, right? Because a lot of this activity actually is not perpetrated by bots, by scripts. It's perpetrated by humans, right? And humans are less predictable than bots, right? And then they coordinate much less, right? So you have patterns that stand out much less, and so it's much, much harder. And another difference is that for sort of unwanted activity, on bot activity, we can perhaps fight this fight on economic grounds, right? So we can make it more expensive for attackers to do these activities, or we can make it less profitable, right? But here, maybe monetization is not necessarily the first goal, right? What we do for spam or fraud doesn't really apply here. Okay, so it's quite hard, right? So I think pretty quickly, in our group we realized essentially two things. Right? The first one is that online services do not exist in a vacuum. Okay, that's a pretty easy observation if you think about it, but it took a while because a lot of the work back then was really focusing on one platform at a time. But these for instance, even social networks, these things, they really influence each other. What gets posted on one platform gets maybe then amplified by another platform, and then spreads on all the other platforms. Let's say, right? And this applies to content providers, applies to news providers, and all of these things are there's a very complex interplay between all of these ecosystems, right? So this was our first observation. And the second one is that there are players in these ecosystems. They are considered like fringe web communities, so like not maybe mainstream social networks or news services that actually play a really crucial role in this information weaponization, right? So there are places like 4chan, 8chan, Gab, or some parts of Reddit, which you might think are these fringe communities, like they're small, and you think, okay, this is just a bunch of losers, shit posting. That's the word that's used, and whatever happens in those platforms stay in those platforms, and okay, whatever, right? Well, that's very, very really untrue, right? So, for instance, platforms like 4chan have been really linked to coordinating hate campaigns that eventually bullied celebrities, minorities, users of places like Twitter. They taught one of the first chatbots by Microsoft, Tai, to praise Hitler and the Nazis. They've played a big role in spreading conspiracy theories. They've been associated to radicalization ideologies where people went on committing mass murders, and I can continue for like 3 hours. Okay, so what we essentially, in a nutshell, we try to do is to have a large-scale, data-driven approach to study and counter some of these activities, and so this obviously entails a very big effort in data collection. Okay, and this is not trivial at all. I cannot overestimate it. I cannot overstate it. So this requires dedicated infrastructures, requires high skills in engineering to get this data, and I'll tell you sometimes why it's hard. And we're talking about terabytes and terabytes of data that we continuously collected for the past 4 years. So really, my colleague Jeremy in Primis is really the person who has driven this unbelievable data collection effort. Okay, so this even by non-academic standards, we're talking about solving real-world systems issues. Okay, so then once we have collected this data, we can use tools, algorithms that allow us to study problems. Right, either do exploratory research and measurements, or actually sort of hypothesis-driven research questions and sort of countering, right? And what I wanted to stress here is that some of these tools are sort of state-of-the-art. There's libraries that we can use. Other tools, we had to adapt them to our context. We had to extend them. And some we actually have to make up from scratch, okay? Especially with respect to influence and interplay. We didn't have a lot of tools in our in the community. And finally, I also want to make sure that, to stress the fact that we're very much, focused on sort of giving back to the community, in that everything that we collect and all the software we've been developing, all these pipelines are all available to the community. So it's not only open access, it's actually open source. And we have facilitated sort of other work also in maybe more qualitative or social science side of things. Okay. So, and in particular, I want to give like one example of the kind of work that we've done. So focusing on this 4chan place. I don't know if you heard of them. If not, maybe you're lucky. But so they're really, so first of all, a big creator of internet culture. So think about, let's say, memes, right? So they have, things like the lolcats. They've had as a coordinated platform for Anonymous. They've really mastered the trolling And they've also been linked more and more, perhaps, to sort of alt-right and far-right ideology, a symbol of hates like Pepe the Frog, and so on and so forth. Okay? So what is 4chan? Well, it's essentially a forum, an image board forum. It is organized in boards, and you can create a new thread in that board by making a post, and that post has to have an image. So that also explains a lot why they create a lot of new content. Okay, so every post, every new thread has to have an image. Other users can reply, and so these are the boards that are active at the moment. There are like 70 of them, and so we focused in particular on one called Poll, Politically Incorrect, that really has, first of all, no moderation, pretty much. Everything goes, except for child pornography. Nothing gets deleted. Maybe if it's off topic, or if they refer some rival platform like 8chan or something, right? So we really looked at this platform, and one of the two of the key features of this are anonymity and ephemerality. So I didn't mention that. So there is no really concept of account. Everybody can post. Maybe you have to solve a CAPTCHA. You cannot use like Tor or VPNs to post, but you don't need an account. You don't have to register an account to post. So everything is actually by default anonymous. There is just some numeric identifier within that thread, but nobody knows who you are, essentially. Right? And also ephemerality, so all threads get archived after a while and actually deleted. There is a complex mechanism to determine what gets archived, but eventually every thread gets deleted. So there are several challenges in studying 4chan. So one is that, like I already mentioned, actions are not limited to that platform. It's not your typical platform, so you have this anonymity and ephemerality, which makes it also harder to collect data and collect it ethically. Right? And knowing what they're talking about is not easy at all, so they have their own lingo, their own sort of internal jokes and memes, and these evolve, right? They're not static, right? To the point that now, we have become a meme into 4chan. Okay, so they accuse each other of being us, for instance, when they have fights, and this is relatively new. Okay, and it's actually also risky for researchers. You might get attacked, you might get doxxed. So that also means that you have to learn how to put mechanisms in place to protect yourself, to protect your students, especially. So we had to learn this as we went. Okay, and in particular, we look at this phenomenon of raids. So there are coordinated hate campaigns that originate, for instance, from 4chan and target users on another platform. For instance, YouTube. Okay, so an example is somebody posts a link to a YouTube video by activists, some minority or someone they disagree with, and so the 4chan thread becomes an aggregation point, and the users coordinate attacks on that YouTube comment, on the YouTube video. And so, so the first step we took was to learn how to recognize that a thread was taking place. And in a nutshell, we can use signal processing tools to understand synchronization between activity in the 4chan threads and hateful activity in the YouTube comments. Okay, so here is an example. This is a video of me, although you can see Gianluca, giving a talk about our first work on 4chan. Okay, so somebody couldn't attend the talk. They asked me to put the video online. I did, and then I was being interviewed by a journalist from the Times, I think, and so I said, oh, by the way, here's a video, so if you want to learn more, you don't want to read the paper. And the journalist linked to that YouTube video in their press coverage, and long story short, this ended up on 4chan. So within like a space of 20 minutes, the video got 11,000 views. I mean, come on, like no academic gets this kind of views. But you can see really the kind of, there were hundreds and hundreds of comments, really hateful, and I apologize for some of the hate words in here. Okay, so this is an example of a raid. Okay, so the first step was to learn how to detect it in an automatic way, and the second step was actually to try and predict it. Right, so can we proactively prevent some of these things from happening, or at least have raise a red flag so that YouTube can take some actions the owners of the videos can, protect themselves, can, I don't know, disable the comments, for instance, or, we could maybe step up the hate detection tools that are used on YouTube. So this was kind of like a complex machine learning machinery. It was called an ensemble classifier, and it turns out that we could actually predict it with high accuracy. So we can determine whether a given YouTube video, even at the time of upload, is likely to receive a raid. And here you have to balance very well false positives and true positives. And again, buy me a drink or buy a drink to Enrico, who did most of the work, and then I can tell you how that went. Okay. All right. So overall, over the years, we've done a lot of work in this space. These are just examples of the things that we did. So we did this work on, got best paper at IMC, where we learned, we measured the influence of social networks, platforms with respect to creating weaponized memes, so memes that are politically charged or racist, highly racist and anti-Semitic memes, and then we looked at things like cyberbullying and many other things. Okay, so to the point that actually we had some of these jokes accusing us, and instead of focusing on, let's say, winning the Turing Award, we were sort of maybe becoming meme scholars. Okay. And so this is like a meme within a meme. Okay, it's called a distracted girlfriend meme. Okay. Anyway, so overall, I want to close here, and overall, I really need to please give me like 2 more minutes to just thank a bunch of people. First and foremost, my wife, who not only moved with me to London so that I could take this job, took a year off to raise our little one. And so took time out of her job, but also for the incredible support over the years. She's somewhere outside taking care of our daughter. So with going through the ups and downs of our work, the anxiety attacks, the stress, the disappointment, I really have no words to thank her. She's like rewritten a lot of broken English for me. She has sat through like an amazing number of presentations that I wanted to practice. So really, there is absolutely no doubt that I would not be here by far without her. So I really want to thank her on record, on the camera, and of course, my family as well, that unfortunately couldn't travel from Italy for this because of what. My extended family in Iran as well. Then obviously, really a huge thanks to my advisor Jean, not only again for traveling from California for this, but for teaching me everything that I know and making me a much better person before, like a much better researcher. I have no words to thank you, Jim. I also want to thank, of course, my students who've kept me on the line over these past few years. They taught me a lot of things. I've learned from them. I've started working on new topics with them, and without them, I would have not learned them. I also want to thank, obviously all my co-authors, but in particular some of them who I have worked with like multiple times over the years. Many of them are here. This iDrama lab that we created. Some, are spread around the world. They made it really fun to work, right? And maybe sometimes we might be a little bit unorthodox and politically incorrect. It's maybe our coping mechanism, for some of the crap that we have to see. But really they made it fun, legitimately. I also want to thank my friends from back from Italy, from undergrads who are here. Thanks for coming. Also, I wouldn't have made it in London, especially at the beginning, without you guys. At the beginning, I hated it. So I was comparing everything with California, so it was a bit hard. Anyway, and I'll just shut up. Just finish with like one of my favorite quotes, maybe somewhat related to what we do. But thank you very much. I really, really appreciate your time. Thank you. exciting. So I guess next is Jean. Have fun. I'll see you in please.
Just hold it.
I think you can just clip it. Huh?
Oh, jeez.
So this will not be anything technical. So in the US, where I come from, this country is known as the land of peculiarities and eccentricities. And I think this ceremony here classifies as one of them. I've never, been to anything like this before. It's very interesting. It's not over yet. Just you wait. So I don't get to do things like that often, or ever. So I don't really know, because you see, being kind of a trained monkey using PowerPoint for the last 20 years in front of students, and I think even to my children I just give PowerPoint lectures. So today I decided not to make a PowerPoint presentation, and actually I stepped in mud because I realized I'm a disorganized note taker. So, most people will put a nice list what to say, and I'm like, I don't know, what order am I supposed to do this, and how long is it going to take? So bear with me. I will be jumping around. The life of a faculty member, of a professor, is in the United States, probably very similar to here, has 4 pillars, right? It has teaching, service, mentoring, and research. Probably the same here. We're evaluated on those 4 skills. Everybody knows what teaching is, right? Boring. I'm a mediocre teacher. Service, we gotta do it. I don't do it with passion. I do it because I have. Research is my passion. I am, for the last 25, 30 years, I view it as a kind of a drug. But it's a good one, like caffeine. It keeps me going. And so one of the things that I try to do when mentoring PhD students is get them addicted. I keep telling them stupid things like, you have to be addicted. You have to love it. Because if you don't love it, there's just no faking it. There's no Viagra for lack of research. You can't fake it. You gotta do it. And so it pleases me to no end when I find a student who actually gets it. Needless to say, Emiliano is one of those. And so I've been doing this stuff, security, privacy, for the last almost 30 years, although I've been an academia proper for only 25. But I've been interacting with students even when I was in industry. And so one of the pleasures of the job is interacting with PhD students and this whole thing of mentoring. Right? Seeing them come in, sometimes in the US we do this, we allow them to come in with a PhD program, with a bachelor degree. They're blank puppies. They have no idea. They have good test scores, but we have no idea what they can do, and they have no idea what they can do. They think they know, but they don't really know anything. Well, by the way, I'm not talking about Emiliano here, because he was actually one of those. I was looking at, so for every student, you might say, I spent 5 years early in my career in Switzerland, so maybe because of that, I have files for every PhD student. And actually, I have a bunch of emails there. So I look back in my laptop, and there's an email from Emiliano dated December 2006. Saying, I attended your summer school, and my advisor in Salerno recommended I get in touch with you. I wanted to, I'll show you to you if you like. Right, but he was not one of those blind puppies. No. He made my job a lot easier. He was actually one of out of about 25 graduated PhD students, he would be in the top 20%, the top 5. I don't want to rank those top 5. They're all excellent. But he's among them. He's one of the 3 that remained in academia and remained in research and have succeeded. This event today is a testament to that. So I'm super proud of all he has accomplished in the relatively short time, 9 years, I think, just about 9 years since graduation. Actually, I think it's rather exceptional because I can't think of any other student of mine or any other students that I know that have accomplished this much in a mere 9 years after graduation. So it has been a kind of a wild ride for you, and it's been exciting to watch from myself. But back to when Emiliano came, he already knew a few things about research. He didn't come from some, what we call Padunk, New Jersey, or some unknown place. He came from Salerno, which has actually produced over the years quite a lot of excellent researchers, and particularly in security and privacy. I'm still wondering, what is it about that region of Italy that produces people like that? Is it sort of a Byzantine history of conquest and subversion? I don't know. I don't want to be politically incorrect, but there is something there that produces people like that, and I think I'm glad for it. I'm glad for it because I've had over the years 3 students that came from that general area for that and have all been very successful. Just a few things about Emiliano. He was easy to work with. It was not a struggle like with some students where I had to really spoon feed them things. Like, open wide, here's research problem. Open wide, oh, why don't you swallow now? Okay, it's gonna get easier. Oh, poor baby, your paper got rejected. Oh, nobody loves you. Okay, no, none of that. He was an adult. He was much more mature than research-wise than your typical PhD student. So some of these growing pains were avoided. Not everything. Not everything. I mean, over the years, we had to get rid of some Italianisms in writing English. I mean, there were a lot of chopping down and flowery expressions that had to be expunged and tortured things that had to be untortured. By the way, I had nothing to do with it, but also certain fashion statements had to be modified. I cannot explain further without getting politically incorrect. But I'm sure Emiliano will tell you, even if you buy him a very small beer, you know. There are some funny moments. But overall, I would say he was, as a PhD student, he was like a Renaissance man. He did everything that I wanted a PhD student to do. He could do theory, he worked in cryptography. Some of the results he alluded to in the beginning of his talk were fairly deep and theoretical, and I'm very proud of the work we've done. He was an instrumental participant in many of these efforts, if not the key participant. In some of them, he then was a very competent systems person. He actually built a lot of stuff that we designed. So this is a rare combination. And then he was also a team player. So I could work with him alone, he could work on his own, and he could also work well in a team. And so this is what I think eventually makes a very successful academic. Not somebody who just crawls into a hole and says, well, I'm just going to solve my own little problems and nobody, I don't care if anybody likes it. Or always a member of a large group, like a cast of thousands who publish papers where the author list is bigger than the paper. You know, we've seen those. No, he's actually somewhere in between. He can do that, this, and the other. And an advisor couldn't ask for more. I think that is where I look at his trajectory post-graduation, his move to Xerox PARC, where I think was an invaluable experience in learning a few things outside of the somewhat rarefied academic air, learning how the real world ticks, and then realizing that actually his real calling is academia, coming back to the world of research and teaching, and finding a very good home at UCL. And so I'm very, very heartened to see that, very happy, and congrats to Emiliano and congrats to UCL for having him. And I think I won't waste any more of your time. Thank you very much.